Good morning, guys. Uh, I hope you are all okay. You're in the lockdown. So, first, today we will be doing another example of mixed design. The yesterday's class we have discussed one example of mixed design, but the example was without any admixture, either it be chemical or it be mineral. But today that we will be discussing our example that is the most important, because here we will be using our mineral and chemical admixture. Mineral admixture, that means cementitious materials like fly ash and GGBFS, that is the granulated blast furnace slag, that we are generally used in the mixed design. But because in the table figure number 1 in the mixed design IS 10262, if I open table number figure number 10262, if I open table mixed design code, if I see in table number 1, here it has been said that for PPC and PSC, for PPC and PSC. So, for PPC and PSC, PPC means Portland Pozzolana cement and PSC means Portland slag cement. So, for Portland Pozzolana cement, what is the ingredient that is used in the Portland Pozzolana cement that is used is a pozzolanic material, which is basically fly ash, and Portland slag cement, as the name suggests, it contains blast furnace slag. So, as per the IS 10262/2019, the admixture, mineral admixture that are specified as per this code is either fly ash or GGBFS that we are using. And then comes the chemical admixture. In the case of the chemical admixture, as it has been specified that water reducing admixture, here it is specified in clause number 5.3 that the water reducing admixture or the plasticizer and superplasticizing admixture is a superplasticizer. They are the two chemical admixture that is specified by the IS code. So, in this today's example, we will be doing an example where we will be using this mineral admixture. Either it may be fly ash or it may be GGBFS as it is specified in the math, and plasticizer or superplasticizer as it is specified in the math. So, we will be doing today these two examples of mixed design. Okay, considering all the other criteria are there. So, first we will be seeing our math today. Okay, so I think you have gone through the previous days lectures of mixed design, that is the what are the procedures, steps and checks. I think you all know that, and also I think you all know what how to do a mixed design. So, today's lecture will be based on this using mineral and chemical admixture. So, for today's lecture, grade designation is M40. Okay, so for today's lecture, the grade designation is M40. That means FCK is equal to M40. Now, type of cement, it has been specified that OPC 43 grade. Now, coming to the mineral admixture, type of mineral admixture used, it is GGBFS, that is the gram granulated blast furnace slag. Coming to the maximum nominal size of aggregate 20 mm specified, exposure condition severe for RCC, workability 120 mm slump, method of concrete placing pumping, degree of supervision very good, type of aggregate crust angular, maximum cement content as per 456. We know the maximum cement content we have to take as per IS 456. Chemical admixture that are using is superplasticizer, normal superplasticizer. Now, specific gravities are given for cement, for GGBFS, for coarse aggregate, for fine aggregate, and for chemical admixture. Water absorption. Now, the water absorption and the free moisture is also given. Water absorption and free moisture, these are the given, and the sieve analysis of fine aggregate is as per zone 3. So, all the data are given. Now, we will be proceeding with our math. Okay. So, the what is the chemical admixture that has been used? That is a superplasticizer. And what is the mineral admixture that has been used? Is the GGBFS, that is a gram granulated blast furnace slag. So, we will be proceeding today with this example. So, first let us in the next previous another slide, let us open the mixed design procedures that I have discussed with you in the first class in the mixed design. We will be opening that too also. So, it becomes clear to you. So first coming to step number 1. What was step number 1 is calculation of the target mean strength. That we know how to calculate the target mean strength for mixed proportioning. Now what are the formula for target mean strength? FCK dash equals to FCK plus 1.65s or FCK dash equal to FCK plus X. So these formulas I have written here. Now coming to where from the value of S and X, S for the standard deviation and X another factor, where from these two are taken. S is taken from table number 2 and X is from table number 1. Now let us open IS 10262 again. Let us open the IS 10262 again. So here we can see that for table number 1, for we are taking FCK value is equal to 40 Newton per millimeter square. So for 40 Newton per millimeter square, this is the value of 40. We are getting value of X equals to 6.5. So value of X we have taken 6.5 and value of S for that equals to will be, value of S for M40 concrete will be 5.0. So we are taking S equals to 5.0. So X and S has been taken. Now coming to FCK dash. Now FCK dash formula, if we put the values 40 plus 1.65 S and 40 plus 6.5, we are getting two values 40.25, 48.25 and 46.25 by putting all the calculations. So what value we should take? This is the higher value. So FCK dash we are getting this value, that is the 48.25 Newton per millimeter square. So we have got our target mean strength. We will be designing the math based on this value. Now coming to again our note, that is the check number 1. What is the check number 1? Above values, that is the above value of S, corresponds to good degree of site supervision and site control. For any other deviation from the qualities of good supervision, it should be termed as fair, and the values in table number 2 shall be increased by 1. Now in our math, what is the site control condition given? Degree of supervision good. So as per this, there is no change. As the site control good, no need to adjust. So no adjustment. So no check 1 will be done here because the site control is good. Now coming to the check step number 2. What is step number 2? Step number 2 is the approximate air content determination. So first we are finding the air content. Now air content depends on the maximum nominal size of aggregate. So maximum nominal size of aggregate is 20 mm. So maximum nominal size of aggregate is 20 mm. So you will be taking the value for 20 mm. What is that? 1% is the maximum nominal size of aggregate. So we are taking the value. So for M20 concrete, the maximum volume of the entrapped air, this is the entrapped air volume. So 1%. So 1% of it should be written there, 1% of 1 meter cube, because we are determining for per meter cube of concrete. So 1% of 1 meter cube of concrete. Clear very much. Now coming to the step number 3. For step number 3, that is a selection of the water content. The selection of the water content. Now how? Selection of the water cement ratio. My mistake, sorry, selection of the water cement ratio. Now I have told you that how to determine the selection of the water cement ratio. It is determined based on the table chart number, figure number 1. So this is the figure number 1. Okay, let me first clear all these values, then we can get a clear picture here. Okay, let me clear all the values, we can get a clear picture. So let us take a value here. So what is the for OPC 43 grade? So what is the curve for OPC 43? For OPC 43 grade, we have to take curve number 2. So this curve is our required curve, and coming to the target compressive strength, that is 48.25. So 48.25 will stay just near to that, I think. Okay, this is near about 48.25. So let us draw a straight line from here. If we draw a straight line like that, it is bisecting at that value. Okay, bisecting near about 0.35. Okay, bisecting near about 0.35. So this value to be taken once again. So as it is bisecting near about 0.35, we are taking the water cement ratio, trial water cement ratio for us to be 0.35. Okay, so this will be our trial. This will be our trial water cement ratio. Okay, this is the, sorry, one second. So this will be our trial water cement ratio 0.35. So this value has been taken 0.35. So we have got our trial water cement ratio. Let us design with that value. Now the checks has to be applied. So check number 2, in absence of data for cement PSC and PPC, the water cement ratio 28 days compressive strength value to be taken for curve number 2 of figure 1. So here let us check what is the type of cement that has been given, that is only OPC 43 grade. So no need for check number 2. Okay, so it has been said that as there is concrete cement is OPC, no need to adjust. So no need for check number 2 to be applied. Now coming to check number 3. What does check number 3 says? The trial value of the water cement ratio shall also be less than the maximum water cement ratio for required exposure condition as per table 5. So we don't need to open IS 456 because the table 5 I have written here for you. So you can see here for what is the value of So now what is the condition as given here? If the condition is severe condition and for RCC. So for severe condition, this is a severe condition and this is for RCC. So for severe condition, what is the value of maximum free water cement ratio? It is 0.45. This is the maximum value of the water cement ratio that we can provide. So the water cement ratio should be less than that. Now what is our trial water cement ratio? It is 0.35. So it is less than that. So hence it is okay. So this check has been satisfied. Okay. So we have done check number 2 and 3 and we have got the trial water cement ratio to be 0.35. So we will be designing the design mix based on that. Now coming to step number 4. What does step number 4 says? Step number 4 says the selection of the water content and the admixture content. So the water content and the admixture content needs to be selected now. So the water content and the admixture content needs to be selected. So the water content and admixture content depends on table number 4 of IS 10262. So this is the table number 4 I have written here for you. So water content firstly depends upon the maximum nominal size of aggregate. So in our math, what is the maximum nominal size? 20 mm. So for 20 mm, what is the nominal water content required? 186 kg per meter cube. So 186 kg per meter cube, that value we have taken per meter cube. So 186 kg per meter cube of concrete, this is the weight of the water we have got. Now that we know that value, this chart is only applicable for angular coarse aggregate and 50 mm slump value. So we have to apply the check number 4 if the shape of the aggregate is not angular, if the shape of the aggregate is either gravel or rounded or any other type of aggregate. So let us check what is the shape of the aggregate. Crushed angular. So angular shape of aggregate we are using, so there is no need to apply for any check. So check number 4 will not be required. Check number 4 will not be required. So we will not be requiring check number 4 as the angular coarse aggregate has been used. No other aggregate has been specified. Now coming to So no need for check number 4. So coming now check number 5. What does check number 5 says? Check number 5 says the workability for slump value other than 50 mm. So let us check what is the slump value given. Workability is 120 mm slump. So it is a very high slump value. So what is the increase? So we have to apply this check. Now first let us check what is the increase in the slump value. So slump value it is given 120 mm. So increase in the slump value, if we take the increase in the slump value is 120 minus 50, 70 mm is the increase for the slump value. Now let us apply the check. Now what is the check? Apply for additional increase and decrease of the slump value. Increase the decrease the water content as per this formula. For each 25 mm increase in the slump value, 3% increase in the water content. Now let us take the line for each 25 mm increase in the slump value, increase the water by 3%. That is the formula given by also in the IS code. Okay, so you can apply the check here. Now for 25 mm we have to increase 3%. Now for 70 mm what we have to increase? For 70 mm we have to increase the slump value by applying the formula here. We are getting 8.4%. So we have to increase the water content by 8.4%. So let us provide water content 8.4%. So water content that we have providing is 186 plus 186 into 8.4% because we have to increase the water content as it has been said here, increase in the water content. So putting all the values, we are getting 201.62 kg per meter cube. So this is the amount of the water content that will be provided. Very much okay. So check number 5 is done. So here we have used the slump value test, and as we are getting a higher slump value, we have to apply this check. If the slump value increases, then you have to increase the water content also. Now coming to check number 6. What is the check number 6? Check number 6 says the very important check, that is if we use plasticizer or chemical admixture. Check number 6 is for chemical admixture. So if we use plasticizer or superplasticizer, that is the chemical admixture, the water content is decreased by. So we have to ask what is the role of plasticizer or superplasticizer. They reduce the water content by keeping the workability same. So that is the basic work of a plasticizer or superplasticizer admixture. They reduce the water content. That means if they reduce the water content, the strength, the water cement ratio will also reduce, and if the water cement ratio will reduce, the strength will increase but the workability will decrease. So what is the superplasticizer or plasticizer does their work there. They help in reducing the water content, and thus by reducing the water cement ratio also, but they do not affect the workability. So by using the plasticizer or superplasticizer, that is the chemical admixture, we can reduce the water content. Now what is the reduction of the water content? If plasticizer used, the water content reduction is 5 to 10%, and if superplasticizer used, water content reduction is 20 to 30% and above. So let us check what is the admixture we have used here. They have specified superplasticizer as their admixture. So I have assumed here 20 to 30% we have to decrease, assuming 25% reduction. It may be 20, it may be 30, it may be more than that, assuming a 25% reduction in the water content. So we are reducing the water content by huge 25%. So the adjusted water content now will be what is 151.215, because we are decreasing the water content by that value. So that is equal to 151.215 kg per meter cube. We are decreasing the value. So this value should be deducted from 201.262. We are getting 151.615 kg per meter cube. That is the now coming to the actual water content. Now you may have a question, sir, that is we have to apply this value to the actual water content 186, but that is not true. Because why? Each checks to be done consecutively. That means after check 4 we have to apply check 5 to the adjusted water content in check 4. That means if we have any reduction in the water content in check 4, then the second check, that is the check number 5, to be applied on the reduced water content. So all the checks are to be used consecutively. Okay, so no need to apply the checks. This will be wrong to apply the checks at the first. So each checks will be applied consecutively. Okay, so this is the actual water content we are providing. Now then we have to apply the dose also. Now what is the dose of superplasticizer or plasticizer? So as per IS code, it has been said that the plasticizer varies from 0.1 to 0.4% and superplasticizer is vary from 0.5 to 2.5%. So this percent by the weight of the cementitious material. So this is the percentage of weight of the plasticizer or superplasticizer, by the weight of the cement or the cementitious material we will be using. So what is as it is 0.5 to 2.5, taking a medium value, that is 1.5% by the weight of the cement. So this will be the weight of the cement, and this so it will be calculated at the time of calculation of the mix proportion. So what will be the weight of the admixture? So assuming the dosage of superplasticizer 1.5% as the code suggests. Okay, now coming to step number 5, calculation of the cement/cementitious material. Now when we are applying step number 5, so first cement content we have to calculate. Now cement content, the formula is water content by calculated water cement ratio. So what we have got, the cement content, water content 151.215, that is the last final adjusted water content we have got. So putting the value 151.215 here, then the value of the calculated water cement ratio. So what is the trial water cement ratio for our case? The trial water cement ratio is 0.35. So putting these two values, one is 151.215 and 0.35. So 432.04 kg per meter cube is the total cement content, that is the cementitious material. Now coming to check number 7, that is a very important check. Now what is this check is for the mineral admixture. What type of mineral admixture we have used? In our math, that is the mineral admixture is given is GGBFS. It is given here, that is the gram granulated blast furnace slag. Now first, it has been said that for this case, when GGBFS or fly ash is used, then the cement content is termed as cementitious material. That's why I am writing it as cementitious material, weight of the cementitious material. This will be not just cement, it will be cement plus the mineral admixture. So that is called cementitious material. So cementitious material it will be termed. So cementitious material content which is cement plus mineral admixture. I have told you that. So now if any mineral admixture is used, it is specified here. For this case, the cement content of the cementitious material but calculated above by the above formula will be increased by 10% weight. So the value we have got, that is the 432.04, we have to increase this value by 10%. So increasing the value, that is the adjusted weight of the cement content, that is 432.04 plus 43.204, this is nothing. So 42.304, that is 432.304. Wait, now if we multiply these two values, 432.04 into 10%, we have got 43.204. So we have to increase the total cementitious material by 10%, as it says that. So increasing the material, we are getting 475.25 kg per meter cube. That is the total weight of the cementitious material. That means cement plus the mineral admixture, as the code suggests. So this is the total weight of the cementitious material. Now in between that, we have to find what is the weight of the mineral admixture and what is the actual weight of cement. Now coming to there, that is the fly ash to be used as per clause number 8.2.5.4 IS 456/2000. It is said that the fly ash to be used is 20% by weight of the total cementitious material or more, 20% or more, and GGBFS to be used is 50% or more of the total cementitious material. No, so as we are using the GGBFS, we have to apply GGBFS 50% or more. So taking the material to be 50%. So assuming the GGBFS to be used 50%, assuming GGBFS 50% or more. So we are assuming 50% material, 50% GGBFS. Now if 50% in between this weight, 50% is GGBFS. So what is the weight? 50%, that is the 0.5, that is 237.62, that is the weight of GGBFS, and the rest is then cement. So cementitious material means cement plus the mineral admixture. So we are getting the weight of the mineral admixture. The total weight of the cement is now 237.60. This is the weight of only cement. So if we sum these two, we are getting the weight of the total cementitious material that we will be using. So this is the weight of the cement. Now coming to check number 8. What does the check number 8 says? The check number 8 says maximum cement content to be checked as per IS 456 clause number 8.2.4.2. What is the clause says? Maximum cement content not including fly ash and GGBFS. That means the only maximum cement content without the use of fly ash or GGBFS, should not increase 450 kg per meter cube. Now in our math, what is the weight of the cement? Only cement we have got, that is 237.60, that is the weight of only cement we have got. So for 237.63, now it is less than 450 kg per meter cube. This is the only weight of the cement. So hence this clause is also satisfied. So the maximum cement content we have got is actual. Okay, now coming to the minimum. This is the maximum cement content. Now also the minimum cement content has to be checked. Okay, so this is the actual maximum cement content that we have been that has been checked. Now here it is said also that finally the adjusted water cement or water cementitious material ratio is calculated. Now as we have seen that the weight of the total cementitious material has increased. Okay, so weight of the total cementitious material has increased here. we can see here that is the first cementitious material was 432. Now by increasing 10%, it is now 475. So the cement content has increased, so cementitious material content has increased. So the water cementitious material ratio will also be changed. So what will be the adjusted and final water cementitious material ratio? This will be the final water cementitious material ratio. Adjusted water cementitious material ratio is the weight of the water that we have got here, 151.215. There is the final adjusted water content, and what is the final adjusted cementitious material content? 475.25. So putting these two values, we are getting 0.32, which is many less than 0.45. So the maximum water cement ratio content is also satisfied. Okay, so we have got in our math the weight of the total cement, weight of the mineral admixture. We can also calculate the weight of the chemical admixture by the required doses that we have assumed. We know the weight of the water. We have also calculated the volume of the air content. Now finally, the last thing that is remain, that is the weight of the and volume of the coarse and fine aggregate. So next proceeding step number 6 is the estimation of the coarse aggregate proportion. So first we have to I have always told you that in this step we will be assuming that we will be determining the coarse aggregate volume. That means if it is the total volume of the aggregate, how much is the volume of the coarse aggregate. So if we know that total volume, and if this total volume is 1, so 1 minus Ca, we will find the Fa. This is the funda that we will be using here. Now the volume of the coarse aggregate per unit volume of the total aggregate. So it depends on three things. Number 1 is the maximum size of the aggregate, and number 2 is the zone of the fine aggregate. 0.5 is the standard water cement ratio they have assumed. This check will be done later. First we have to take the what is the value. So let us check the value. So for 20 mm size aggregate and zone number 3. So let us check what is the zone given in our math. So zone number 3 it is given, and what is the maximum size? That is, it is 20 mm. So maximum size 20 mm and zone number 3. So for maximum size 20 mm and zone number 3, the value is 0.64. So putting the value here, 0.64 meter cube. Now, so this is the value of the volume of the coarse aggregate in the total volume of the aggregate. This is 0.64 meter cube. Now coming to check number 9, that is the important check. Now this table, this value is only for 0.5 water cement ratio, but we have got the water cement ratio to be 0.32. So it is much more less than 0.5. So we have to apply the check. What does the check says? If the water cement, wait 1 minute. It says that if the water cement or water cementitious material ratio decreases by 0.05, then we have to increase the volume of the coarse aggregate by 1%. That means if the volume of the water cementitious material ratio decreases by 0.05. So let us find what is the decrease in the water cement ratio. The decrease in the water cement ratio is 0.18. So for 0.18 we have to apply the check. Now for 0.05, then the increase in the volume of the coarse aggregate by 1%. We have to, for 0.05 we have to increase the volume of the coarse aggregate by 1%. Now if the decrease in the water cement ratio is 0.18, then the value will be increased by, then the volume of the coarse aggregate adjusted will be, we have to apply the increase. So we are getting the value here. We have to apply the increase. Okay, so 0.6 is the first calculated value. We have to increase by 0.101, that is the for 0.05. So applying the formula, and we are getting 0.663, that is the volume of the coarse aggregate. Now we cannot find yet the volume of the fine aggregate because final check has to be done. That is the check number 10 has to be done. So what does the check number 10 says? Sometimes to ensure better workability, I think up to that this is clear how to apply the check number 9. Okay, so we have got the fine adjusted volume now is 0.663. Now the check number 10 will be applied similarly consequently in 0.663 only, because this value is adjusted value. I have always said that in the mixed design apply the values in the calculated, that is the adjusted values. So this value we have calculated, that is the adjusted value. So the check number 10, if there will be any check number 10, that check number 10 will be applied on this value only. Okay, so let us check if there is any check applied in check number 10. So for better workability, or concrete is required which is placed by help of hydraulic pump system, that is called the pumpable concrete. Okay, so pumpable concrete, for pumpable concrete as per clause 5.5.2, that is if we come into the clause 5.5.2, it says that for more workable concrete by pump we have to increase aggregate content determining in table 5 up to 10%. So we have to increase up to 10%. So up to 10% we can increase the total water content, total coarse aggregate content. So what is the calculated coarse aggregate content? 0.663. Now we have to reduce by up to 10%. So now, let us let us check what is the type of concrete placement. Here it is said the concrete is placed by pumping method. The concrete has been placed. So now if the concrete is placed in pumping method, we have to apply this check. Now let us apply the check. What does the check will suggest? That is the reduction of 10% will be applied. So we are assuming 10% reduction in the total coarse aggregate content will be applied here. So reduction in the coarse aggregate content by 10% into 10, that is the value we are getting by applying the check. 10% water content, 10% coarse aggregate content, the final adjusted volume of the coarse aggregate we are getting is 0.5963. that is the final adjusted volume of the coarse aggregate. Now as we are getting, we have got the final adjusted volume of the coarse aggregate, we can now determine the final adjusted volume of the fine aggregate also. So if, let us come to the picture, if this is the volume we have got from the coarse aggregate, so what will be the volume of the fine aggregate? 1 minus this volume. So putting the value 1 minus this volume, we are getting 0.4033 meter cube. That is the volume of the fine aggregate adjusted. So we have got the volume of the fine aggregate also. So volume of the coarse aggregate and volume of the fine aggregate has been found out. So all the required ingredient values have found out. Some values are in kg, some values are in meter cube, that is the volume. So we have to change all those things. So final calculation, now we are coming. So let us come into the final calculation. So final calculation comes in check number step number 7. So first we have to calculate the calculation of the mixed proportion. So volume of the cement, specific every volume will be weight of the cement by specific gravity of the cement divided by 1 by 1000. So putting all the values, the weight of the cement we have calculated is, final weight of the cement only 237.60. So 237.63 by 3.15, that is the value given in the water, value given in the, for the cement 3.15. So putting the value here, we have got the volume of the cement, that is 0.0754. Now mineral admixture, the weight is similar as to cement because 50% of the GGBFS have been used. So the specific gravity is 3 into 1 by 1000. We are getting 0.0792. Water content volume, specific gravity of the water is 1. So 1 divided by the weight of the water. So we are getting 0.1512. Now coming to the chemical admixture. What is the dosage of the chemical admixture? Dosage of the chemical admixture that we have assumed, that is, what is the dosage of the chemical admixture? Where it is? Okay. Chemical admixture dose is 1.5%, that is the dosage of the superplasticizer, 1.5% by the weight of the cementitious material. So for the cementitious material, let us apply that. So what is the total weight of the cementitious material? Weight of the chemical admixture is 1.5% of the total cementitious material. So final cementitious material weight that we have calculated is 475.25. So we are putting this value 475.25 into 1.5% by 1.145, that is into 1 by 1000, that will be equal to 0.0062. That is the weight volume of the chemical admixture. Finally, the volume of the entrapped air. Now entrapped air suggests that this entrapped air value that we have calculated is 1% of 1 m cube. So what is the volume? 1% of 1 m cube means 0.001 meter cube. So total volume of the aggregate, coarse plus fine. So putting all the, so we have calculated all these values, volume of the cement, fly ash or GGBFS, the mineral admixture, water, chemical admixture, entrapped air. So we are putting all the values A, B, C, D, E we have calculated. Now the total volume of the aggregate in 1 meter cube, that is 1 minus all the values, we are getting 0.68 meter cube. This is the volume of the coarse aggregate in 1 meter cube of concrete. So let us find out the final mass of the coarse aggregate and the fine aggregate. All the values will be put it in this formula. Okay, so putting all this in this formula, 0.68 into all the values, it is 1113.6 kg per meter cube, and here it is there 797.92 kg per meter cube. So this is the volume of the coarse aggregate, weight of the coarse aggregate and fine aggregate after step number 7. So up to that we have to done. This is the required step. Now coming to step number 8. Now it is said if otherwise specified. This is a check for the if any determination of the adjustment due to water absorption or free moisture. In our math it has been given, that is the free moisture and water absorption both are there. So first we have to write down the values of the x1, x2, y1, y2. Let us put the values. What is the value of x1? The value of the x1 is the water absorption for coarse aggregate. So water absorption for coarse aggregate and fine aggregate and the free moisture for coarse, these are the values. Water absorption for coarse aggregate 0.5%, water absorption for fine aggregate 1%, free moisture of coarse aggregate by 2%, free moisture of fine aggregate by 5%. So let us put all the values. So x1, y1, x2, y2, all the values are there. Now let us check if y1 in between x1 and x2 and y1, y2, which values are greater. So y1 greater than x1, so y1 greater than x1 and y2 greater than x2. No, in our course says if y1 greater than, if x1 less than y1, that means if y1 greater than x1, then total free moisture. So as the total moisture has been given, the moisture given by the aggregate is more than the moisture absorbed by the aggregate. So total moisture has been given. So total moisture. So we have to calculate ZB. So calculate ZB for coarse aggregate, y1 minus x1, putting all the values, 1.5%, 2 minus 0.5, 1.5%, and ZB for fine aggregate, y2 minus x2, 4%, 5 minus 1, this is 4%. So we have calculated ZA and ZB. Now putting the formula. So what is the formula for free moisture? For free moisture, the formula is adjusted mass of the coarse aggregate. We have to find out. So as the free moisture has been given to coarse aggregate and fine aggregate, so the extra weight to be added, because some of the weight has been given as weight of an water to the total mix. So that much weight for the aggregate has to be reimbursed, adjusted. So adjusted volume of the coarse aggregate, putting this formula, that is calculated mass of the coarse or fine into 1 plus ZB for coarse and fine by 100. So for coarse, at calculated mass is 1113, that we have calculated 1113.6, 1113.6 plus 1 by 1.5% is the total free moisture by total free moisture of coarse aggregate. Putting the value, we are getting 1130.3, that is the final weight of the coarse aggregate. And lastly, final weight of the fine aggregate, putting the same value similar way, 4% is the total moisture content. So we are getting 4% of the total moisture content, we are getting 829.84 is the total adjusted final weight of the fine aggregate. So coarse aggregate and fine aggregate, we are getting these two values. Now coming to the, so these are the weight of the coarse and fine. So as the coarse and fine aggregate has been adjusted, so water needs to be adjusted too. So water content we have to determine. So what is the water contribution by the coarse aggregate? That is 1130.3 minus 1113.6, that is the coarse aggregate contribution to the total water, and fine aggregate contribution to the total water is 31.92. So this water has been contributed extra in the mix. This water has been contributed extra in the mix. So from the total mix we have to reduce that much water, because now the water will be more than that. So we have to reduce that much water. As the total moisture has been given, we have to reduce that extra moisture from the actual water. So the actual adjusted mass of the water, will be that much water that we have calculated minus the weight of the water contribution by the coarse aggregate, and that is that, and water contribution by the fine aggregate. That is that. The formula here it is written that the adjusted mass of the water minus water contribution by coarse aggregate or the fine aggregate. Calculated mass by the minus water contribution by coarse or fine. So putting all the values, we are finally getting 102.595 kg per meter cube. So finally at the final stage we have got all the weight of the materials. So let us try the final mix of the material, that is the final result that we will be needing. Okay, so cement we are getting 237.63, it may be written as 238. GGBFS similar, it may be written as 238. Water content 102.59, it may be written as 103. Chemical admixture, now what is the value of chemical admixture will be? The value of the weight of the chemical admixture will be that value 1.5 into 475.25. So 1.5 into 475.25, we can get 7.13 per kg per meter cube. 7.13 kg per meter cube if we put the value here. So this is the doses of the admixture and this is the weight of the total cementitious material. So if we calculate the value, we can get this is the weight of the chemical admixture, 7.13 kg per meter cube we have to apply for the chemical admixture. And finally the coarse adjusted final coarse aggregate content, that is equal to 829.84, writing it as 830, and fine aggregate, it is my mistake, sorry. So the total adjusted fine fine aggregate content is 829.84 that we have calculated here. So it can be written as 830 and coarse aggregate content is 1130.3 or 1130 kg per meter cube. So up to that you have to do in your exam. So all the steps has to be followed carefully and clearly, all the checks has to be done accordingly. So and finally the value of the required mixed proportion of the material, the weight of the materials per 1 meter cube volume of concrete we have to find out. This is the basic motto and the basic result that we need to find out. Up to that, this is the mixed design. So we have to follow all the steps accordingly. All the steps are written in the code. We need to be clear about each step and each checks to be applied. Finally, we can determine the total water cement, the content of each materials that are used in the concrete by this formula. Okay, I think this is clear to you. So we have done two basic math in the water mix design, that is one math without any admixture and one math with chemical and mineral admixture. In your assignment, I will be giving one math to you in which no chemical admixture will be used or no mineral admixture will be used. So one thing will be off, either chemical admixture or mineral admixture. So that math I will give to you in your assignment. Okay, up to that, this is today's class. Now in concrete technology total module in your syllabus, all the modules except module number 7 I think is left, that is the admixture. I have told you in the mixed design class that module I haven't covered yet. In the next week we will be covering and we will be completing the concrete technology syllabus module number 7. Then we will be going for the question answer or if any question you have. So please read it carefully, do the math in your home by yourself. If you have any problem, please feel free to contact me. Okay, thank you students for your time.